Hi, I'm here to introduce you to Opsani. Our mission is to leverage artificial intelligence to help you achieve the greatest possible performance and efficiency for your applications operating in the cloud. To do this, our neural network modifies various settings for your application that can affect performance. These include resources like CPU and memory, middleware configuration variables like JVM garbage collection type and pool sizes, kernel parameters like page sizes, and application parameters like cache timeouts or write delays. We then monitor the performance of the application and feed that data back into the neural network, which learns the nuances of how your application performs. Over time, it's able to tune the performance, exploring options a human would never think to try, and achieve remarkable gains in performance and efficiency. In the field, we've seen boosts in performance upward of 200%, or reductions in costs up to 2/3 while maintaining performance. So, what does this look like in action? Let's take a look. This is the system user interface. We're currently optimizing a simple 3-tier application. To do this, we're going to be changing the database commit delay, the database CPU allocation, the Java Virtual Machine garbage collection time ratio, the Java Virtual Machine memory allocation, web CPU, and the number of replicas. On each pass, we'll be measuring performance as the request per second being served. The AI is already running and you can watch the iterations as they go. Performance started at 150 and it's already moving up. We can look at the current settings being tested. It's increased the commit delay, added cores to the database, hasn't changed settings for Java, and reduced the number of web front ends. Going back to the performance graph, you can see that as the AI changes the settings, the performance is going up. As the AI explored, cost initially went up, but once it found adequate performance, cost is going lower again. The third graph shows the AI's optimization score, which in this case is efficiency. Moving to the details section of our UI, let's take a look at our progress. Performance is up over 100%. Cost is still higher due to the AI's exploration, but that'll decrease over time. Efficiency is also up over 100%. Looking back at our cost graph, we can see the system is still exploring, looking for additional solutions. As the neural network explores, it will continuously get better at finding the greatest efficiency for this application, achieving remarkable improvements for yet another app. And as if on cue, the system has found a lower cost solution. Looking back at our cost graph, we can see it dive to the right, and looking back at our details, we can see we now have large improvement in performance, lower cost, and of course, greater efficiency. That concludes our brief introduction. If you could use a boost in efficiency, we'd love to hear from you.